Now that we've practiced finding the balance in our account based on a principal and interest rate, what I'd like to do is look at how to do this in reverse. So suppose that 5 years from now, I want to have $2,000 in my bank account, and my bank is going to give me 4% interest compounded semi-annually. What is the principal or starting amount that I need to put into this account so that I get this $2,000 at the end of 5 years? All right, so we're going to use this formula that 2,000 is my balance, and that's going to be equal to P. And P is what I'm solving for because that'll be my starting amount. And it's 1 plus 0.04, and we are compounded semi-annually, so N is 2. So the quantity 1 plus 0.04 divided by 2, and then that quantity is going to be raised to the power of 2 times 5, okay, for that 5 years. And to solve this, to solve for P, I'm just going to divide this whole piece over to the other side. So what I get is P is equal to 2,000 divided by 1 plus 0.04 divided by 2, and that quantity raised to the 10th power. So I end up with 2,000 divided by 1 plus 0.04 divided by 2 in parentheses raised to the 10th power. So $1,640.70. So if I go down to the bank and I put $1,640.70 in there and I leave it alone for the next 5 years with this 4% interest compounded twice a year, I'll have the $2,000 I want for whatever I'm going to be spending that on. All right, number 20. What if I want $3,500 in my account after 5 years? And now my interest is compounded quarterly, so 4 times a year, a little bit more often. I'll set this up the same way. My balance is at $3,500, and that'll be equal to P, my starting principal that I want to solve for, times 1 plus 0.04 divided by 4, because N is 4, raised to the power of 4 times 5, so raised to the 20th power there. And I'm just going to do the same thing as before. I'll divide this over to the other side. So I know that P is 3,500 divided by 1 plus 0.04 divided by 4 raised to the 20th power here. When I number crunched that, I got that I needed to put in my account $2,868.41. If I do that and wait those 5 years, I'll end up with the $3,500 that I was looking for. All right, I would love for you to try 21 and 22 on your own. So go ahead and pause the video, give those a try, make sure you feel comfortable solving for P there. All right, so hopefully you tried those out. Let's go through them together and make sure we get to the same place. So at 21, I have 12,855.94 is equal to P times 1 plus 0.0431 divided by 12 raised to the 12 times 10. So P is this $12,855.94 divided by this whole piece on my right-hand side. I have 1 plus 0.0431 divided by 12 raised to the 120th power. And that tells me that I need to start out with $8,361 in my account. And then if I do that, 10 years later, I'll have this almost $13,000 that I was looking for. All right, and last but not least, number 22. So my balance is $5,485.85. That'll be equal to the principal times 1 plus 0.0461. And this is compounded 3 times a year, so N is 3. So 1 plus 0.0461 divided by 3 raised to the power of 3 times 6, because we're doing 6 years. So P will be $5,485.85 divided by 1 plus 0.0461 divided by 3 raised to the 18th power there. 6 times 3 is 18. And when I put that in my trusty calculator, I get that I need to put into my account $4,169 to start out with. So that 6 years later, I'll end up with this almost 5,500.